Hello, I'm Vlad, and I'm glad to share a notebook on colors in scientific graphics. I'll start with this article, The Misuse of Color in Scientific Communication. We'll go through the illustrations and discuss some of the aspects of how we draw figures and what kind of problems we can face. So we can use different ways to show the same. For example, we can apply the color map, which is called jet, and you can immediately identify what kind of problems we can see. That kind of color map allows us to categorize. It actually pushes us to divide the figure into categories. Whether the original one is black and white, clearly we can see a woman, we can recognize an apple and the earth. And here is another way to show it, which is more balanced than the one on the left, the jet one. So this is an illustration that you should be very careful with. Which color maps are you using? There are different. For example, you should account for color deficient vision. Not all of them are great because sometimes you cannot really recognize the difference in shades of colors. And also, then you should account for grayscale as well. And here you can immediately see that this is a sequential color map. There is another way to show, again, the jet one, and you can see that it starts with dark one, then goes through light one, and ends with dark one. And most of the colors are not really distinguishable. I mean that we start with something that we're common with like a rainbow, and you can see here the blue, light blue, green, yellow, orange, red. But in fact, 1% of population will see basically several colors: blue, yellow, dark, cyan, magenta. Color type, let's see that we have continuous, we have discrete, we have categorical, then we have sequential, we have diverging, which means that you, for example, have light in center, then you go to dark to the left, to the right. Then you can have some classes, and you can have something like cyclic. So these are kind of obvious things. I'm not going to discuss them in much more details. You can open the article and read the text. Now we are mostly interested in this kind of decision tree. Let's start with a given data set. We must answer a simple question: has the data an order? If no, then it's safe to use sequential color map, and better to have even discrete categorical colors. For instance, you go to shop, you have a grocery list, and you color the milk dairy products with one color, meat probably with red, vegetables probably with green, and fruits perhaps with orange. Next, if you do have some order, you ask yourself whether the data has a central value, and if it doesn't, then just go for circular, periodic, some kind of cyclic color maps, which are just fun to use. They are not monotonous, and they still allow you to distinguish between different data values. If it does have, then consider using diverging, and that is great for temperatures, for example, because you can set 0 and then you go to negative and positive temperatures. Whether the multi-sequential, I don't know what should be the example, but the point is that you have a border in between your sequences and you can color them with different ranges. Next, for all of them, we apply a simple filter. Is it important that you have small variation? If not, use discrete. If yes, use continuous color maps. And okay, the rest is not so important. It's about choosing the background. Oh, great. After that, we can go to our notebook. I have prepared something for you. So we start with installing some software, some packages, some libraries, and later we will import those libraries in, which is Matplotlib, some mathematical NumPy, some pandas, and Seaborg, and this is tools colors, which is a package for using while it's installing. I will just introduce. This is a great web page discussing how you can choose your colors depending on what you would like to achieve. And this web page with all the recommendations is implemented as a Python package, which we can already use. Now my regular usual recommendations: define the settings according to your general preferences. For example, use one color figure width of about 8 centimeters. For two columns, use 17 centimeters. Oh, again, just check the journal preferences, the guideline. Keep the proportions simple, like 1 to 1 is a square. Maybe you would like to use golden ratio. Of course, that is not obligatory. It could be just 5 to 3. Now, if you find that the figure on your screen is too small, don't change the ratio, don't change the size, change the DPA value. You can zoom in, zoom out using the DPA right here. Next, set all the font size so that you don't need to redo them. They should match the text size in your article, inside your article. So it should be reasonably small, like 10, 9, or 8. Okay, next we generate a simple data. So I just plotted some lines. Now we are going to use Tableau-colorblind with 10 colors in a palette, and you can see how it looks like. According to the definitions shown in the previous article, this is not really sequential, it is more like categorical, you see. So I don't recognize really any order here, but these colors are safe for people with color deficiency. And the same, we can apply some default colorblind set of colors by Seaborg, and again it's kind of categorical. Yeah, and I think that these colors, as you can see, they are repeating after 1, 2, 3, 4, 5, 6 colors. Probably not the same here because we use definitely 10 colors. And the same here, after 6 colors, the color blue is repeated. Okay, now I scroll down, and there is another way to use the Seaborg colors just directly from Seaborg. And again, I'm asking for 10 colors and we get this result. The cool feature with Seaborg is that, oh no, this is not Seaborg. This is this strange package, which is this. Let me go up and read what it's called. Is Distincipy. I have troubles with reading this word. This is again a special package for generating colors where you can change the pastel factor. Let's see how it looks like. You can see immediately the effect. Now it's different set of colors. And again, it's categorical, but I would suggest we focus on those diverging and sequential color maps next. CVDIS is a great sequential color map. Rainbow is something that we will discuss it then, controversial, let's say. So let's see how this rainbow look like. It is, by the way, again, according to this classification, it is cyclic. It can be considered almost cyclic. Although if I put it in a cycle, then red would not really match with blue. But it's also not really so divergent. Next, I will use something which is called Turbo, and this is developed by Google, and it is very similar to Rainbow, but it fixes many troubles with that. Now we can define, as you can see, the colors are discrete, so we can define them with just codes, like I did here, and I took this code from Krzywiński from his webpage. And now the result look like this. This is definitely colorblind safe, but we will see some problems with that because we can differentiate between all the colors. However, in grayscale, it doesn't really look great because their intensity is almost the same. Now I'm using the colors by Toll. He made an impressive analysis. I already advertised his webpage here, and he does explain which color and why should you use. So why not to use the colors from his webpage, and we generate it as well. But also why not to use a specific package and let's say use his colors from a color map called Sunset. By the way, you can change the colors, the names, and you will get the different sequences. And when we plot it, you can immediately see that there is a difference in the intensity of the colors. In the middle, you have pale ones. At the edges, you have very intensive ones. Now, let's plot all of them together, one by one. So now we can kind of compare them. Oh, I wrote here unsafe, but this is a questionable thing. We will see soon. Let's replot again. Ha ha ha. Which one do you like the most? An open question. What do you see here? Think for a moment. Can you differentiate between the colors? Can you see the trends, like the directions in which the colors change? Now we have some description of colorblind types, and we will apply them. We can change this parameter here. Protanopia is what's written here, and if we execute this cell, we will see how people with protanopia see the same plot as we just showed above. And let's see whether they will be able to distinguish. Now, this is a bit different, right? With tall colors, which I choose by just by my eye. And you can definitely see that this one strikes out. So we don't have any sequence here. It doesn't really look sequential or diverging. Whether the left one, that was also chosen by just by naked eye, and it looks fine. The Matplotlib color map, which is turbo now, that is more consistent. It is diverging to this yellow, very nice yellow, and yeah, even with color deficiency, you can distinguish between the colors. The tall map is even more balanced, I think, but it's also very pale. Now let's plot it in gray, black and white. With let's go from left to right. With this, you don't see the trend. Okay, that one is definitely kind of categorical. This one is pretty sequential and even more diverging, and that one is even better. So now it's up to you what you would like to choose. With Matplotlib, the turbo color map is already implemented by default. Oh, by the way, let's make the experiment. So let's put jet. Oh, jet with J, right? Yeah, you can see there is some problem with this jet because these two are not really distinguishable and the center is shifted upwards. Okay, so jet is not the best. Rainbow, let's check this one. That is usually criticized. Not so bad, but again, the center is shifted upwards. Let's go back to turbo. Notice that the color for turbo is more centered. Now, you can find on the internet some very cool and interesting reading about rainbow color maps because people discuss whether it's really totally disastrous and bad or it's actually not so bad. And let's go through those articles. Rainbows, color maps, what are they good or bad for? And I think that was a very long article, yeah, discussing in so many details why one color map is much better than another one. But the point is that indeed, when you use this jet or rainbow, you kind of categorize. It doesn't have like one center, but you can immediately see that it has reddish center, yellowish center, cyan center. So you tend to categorize into those at least three colors. When you have a balanced blue-orange color map, you have the center right in the middle. If it's sequential like this, so you go from blue to white, and the same with Viridis. I don't really like Viridis as well because to my mind it's also not so linear. It does have this green center here. So the study is it's very detailed, but probably the main conclusion is that with some of the color maps like jet, you tend to categorize something. You can see an island here, whether you don't see the same in another color map. So let's skip that article. That's another article where if you use this rainbow or jet, then you see very clearly the peaks, so you can distinguish them very, very well. But this color map doesn't give you the right weight, because if you color it the different way, then you can see that those peaks are not so different from those peaks and from the bluish ones. Whether in jet, you don't really recognize that there was a peak here. And this is another great example, the Maria Skłodowska-Curie picture, and you don't really recognize the face. It's kind of zombie, whether in the original picture it was a normal photography. If you really balance your rainbow-like color map, then you can get this turbo developed by Google, which gives you the right perspective. So you see the critiques was, if you take a look on the right picture, then you get wrong perspective because you see this just red cube, then you have green cube, and then you have some blue things, which does look like we go to some perspective, but it gives you the wrong sense of the space. Whether if you use Viridis, then you get the linear feeling of the space going into the horizon. And with Turbo, you get both. You get categorization, but you also have the right perspective. Please explore the notebook, try different functions, and definitely use wisely all the color maps and colors in your work. Thank you.